All right. Here we go. The disk method. Now, what we've been doing is the last two sections we had a shape like this, and we're making squares and rectangles and triangles and semicircles. And so part of it was a flat surface. Now what we're going to do is we're going to take something like, I could just go like this. And we're going to wrap it around either the x-axis or y-axis. So if I take a rectangle and wrap it all the way around the x-axis, what do I create? A cylinder, a solid cylinder, okay? But they're not always going to be rectangles. They might be a shape like this that they wrap around. So, as your wrap gets bigger, then it gets bigger, and so on and so forth. But we're wrapping all the way around the x-axis or all the way around the y-axis today. So you take a shape like this, and if you look at it three-dimensionally, when you wrap it around, it looks like that. Okay? In this case, it looks like a beehive. Okay? And what we're doing is we're going to do what's called the disk method. We're going to take little discs, really slender discs, and wrap them around, and they're actually going to become that long and in a circle and wrapped all the way around so they look like that. Okay? So when you wrap things around in a circle, the formula is pi r squared. Easy peasy lemon squeezy. Pi r squared from A to B. Okay? A to B of pi r squared, and the radius is whatever this function is. Okay? So when you wrap around the x-axis, you solve for y. Okay? When you wrap around the x-axis, you're going to solve for y. So you're going to just basically replace the r in the expression with what the function is when you solve for y. Well, if we square that, it's just that. We're going to integrate that, take the pi out, integrate, and you'll get 18 pi. Now, if we wrap around the y-axis, we take this and we're going to wrap this around the y-axis. We have to take this function and we're going to have to solve for x. Okay, we're going to have to solve this for x. And we'll go from, in this case, it says from 0 to 2. Okay, so it's going to be kind of a flat top circular thing. Okay, so after we do that, what would we get? Well, if we solve this for x, we're going to get y squared equals 9 minus x squared. Switch the x squared and y squared around, so x squared equals 9 minus y squared, and then square root it. So x equals 9 minus y squared under square root. Okay, so it's basically the same formula. And we're going around the y-axis, and we're going from 0 to 2 of pi r squared. Take the pi on the outside. Pi 0 to 2 of, and then what I would do, I don't like it like this, I would multiply it out. 81 minus 18y plus, forgot my square root. So, yeah, so then, no, that's what I did this morning, and that's why I got Kendra's problem wrong, which led to you guys getting all the answers. Thank you, Kendra. And so then we got 9 minus y, because when we square 9 minus, when we square the square root, then we get, so it's 9 minus y squared, right? Yeah, yep. So then when we do this, it's 9y minus 1/3 y cubed from 2 to 0. So it's pi times 18 minus 8/3 minus 0. So 18 minus 8/3 is the same as 54/3, because 18 times 3 is 54. So 54/3 minus 8/3 is 46 pi over 3. Okay, so this one, we're going to let R be the region enclosed by the x-axis and y-axis, the line pi x equals pi, and the curve sine of x, we're going to rotate around the x-axis, and so on. So it's just the integral for what x's are used, 0 to pi, of the sine of x. So it's pi sine of x squared. Okay, so if we take the pi out, 0 to pi of sine of x squared. So u equals sine of x. What's the first derivative of sine of x? Cosine of x. Ooh, we can't do that. Ooh. So it's okay. Oh, how do we set it up? Yeah, because we don't have to solve it. How do we set it up? Pi r squared. Pi r squared from 0 to pi. There we go. How do we set it up? Because that would be really hard. That would be a calculator problem. Yep. All right. So this one, we're rotating around the y-axis. So if y equals e to the x, what does x equal? Ln of y. X equals the ln of y. So we're integrating from 2 to 5 pi ln of y squared. Pi r squared. Pi r squared, 2 to 5. Yep. Okay, so that's the types of things that we have today. I will put that out. I will put the next videos out. There you go.